the idea is to use our competencies, our know-how in fluid power to really help 3D printing technology to become a mass customization production.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA, and make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is actually one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts, on Spotify, on a lot of the other podcatching services. Wherever you find us, please subscribe and then give us a quick rating. That actually does help more and more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guests are Valeria Tirelli and Alberto Tacconelli. Valeria is the CEO, and Alberto is the General Manager of Hydra, a manufacturer of components for hydraulic solutions. And today we invited them into our forum to learn more about their groundbreaking 3D printing technology and how it's being used to produce efficient and high-quality components for fluid power applications. So, Valeria and Alberto, welcome to Fluid Power Forum.
Thank you, Eric. I'm very happy to be here today.
Thank you, and hello to all the fluid power friends in US.
Thank you. It's good to have both of you on our show. Yes, where I'm talking to you, you guys are in Italy and I'm in the United States. So this is one of our infrequent international podcasts that we're recording. So thank you for connecting with me today. I'm hoping you can tell our listeners a little bit more about your backgrounds, how you found your way into the fluid power industry. Valeria, why don't we start with you?
Yes, of course. My story in the fluid power started almost 15 years ago. So officially, but in reality, since my birthday, I'm living in the fluid power because my father was one of the main, engineers in Italy who promoted fluid power early in 1970s, almost in Italy, and he was one of the main technical people developing application in Italy and in Europe. So that's why I'm grow up inside fluid power, and now I'm the CEO of the company since 2012. So almost more than 9 years.
Did you have any more formal education in fluid power, or just it's part of the family tradition?
No, that's the point. No, I studied business administration at the university. And all my technical experience are really on the fields. So learning in the company, in the family company, because Hydra was founded by my father. So it's was a family business till September this year. And then we will tell you more about also our adventure within Desktop Metal Group.
Yeah. Well,
so my experience is really practical.
And we'll definitely want to talk more about that Desktop Metal acquisition. But before we go there, Alberto, tell us a little bit more about your background and what your career has been like.
Yes, my background is a little bit different because I started my career as a chemical engineer in the chemical plants, in big companies, and dealing every day with fluids, but not oil hydraulics, but chemical fluids, dangerous fluids. And so this type of problem. And 14 years ago, I decided to switch and to change my career, switching from big companies and chemical companies to a small, medium-sized company, Hydra, where I had the chance to develop different competence and also to have different challenges in everyday activities, because in a medium company, it's possible to see from the beginning to the end all the aspects of a company, technical, commercial, and everything.
It sounds like it was a great opportunity for you to move into that environment.
Yes, exactly. And for sure with a lot more problem, because in small companies, everyone has to face directly with the problem, and there are no many colleagues to ask for an help.
Yes.
But also with a lot of more satisfaction, because when we have an idea, we know that we can implement this idea in a couple of weeks without spending time in meetings or PowerPoint presentation.
The freedom to innovate is much more acute in smaller companies in a lot of ways. That's exciting.
Exactly.
Well, tell us a little bit more about Hydro then as a company. Give us a picture of where is it, what does it do?
Yes, so Hydra was founded almost 40 years ago by my father, so Paolo Tirelli, and we are based in Italy, north part of Italy, not far from Milano, but in a very green area near the Lake Maggiore. So we are also inspired by the nature that surrounds us. And so the company was founded to design and produce hydraulics, mainly valve, like seat-up valves. And we developed other, production like 3D printing. And then we will come more about this new technology. And now we are still a small, medium-sized company, but very active in the oil hydraulics fields, especially for the innovation of new product made with 3D printing.
Yeah. So apart from the 3D printing part, your primary products are valves and/or manifolds, or both, or?
Yes. Our focus is on seat-up valves, so NG4, NG6, NG10 valves, and this is the main activity. So valves, solenoid valves, stackable valves, all these type of components that are normally used in industrial application, and in some cases also in mobile application, in the traditional hydraulic market.
So you're in both of the major markets, both industrial and mobile applications.
Exactly. We are 50-50, let's say.
Oh, great. Okay.
And we don't deal with pumps, filters, or cylinders.
Right. Well, as we said, one of the things we want to talk about is what you're doing with additive manufacturing or 3D printing. I guess those terms are almost interchangeable now. And a big catalyst for that, I know, was the recent acquisition by Desktop Metal. So maybe, Valeria, you can talk a little bit more about that. I mean, what is that? Why did that happen? And what advantages is that going to bring to your company?
Yes, that's for sure a very, special acquisition. So I can tell you more about Desktop Metal. That's a quite new company founded in Boston, Massachusetts, 60 years ago. So it's quite a big startup now. But last year they went to the stock exchange, and they decided to create a big group or an ecosystem of different companies, all working in additive manufacturing, but with different specialization. And that's why Hydro joined this big group and this big project, because we bring our expertise in fluid power and in additive manufacturing also to boost the adoption of 3D printing in a mass production of new fluid power generation. So the idea is to use our competencies, our know-how in fluid power to really help this technology, so 3D printing technology, to become a mass customization production. This is something that everybody we are discussing, because additive manufacturing is a perfect technology, but for the moment is a niche volume, so small volume for special application.
Yeah, I just sort of interrupt there. I was just wondering if it's helpful. It's a term that I think most people are familiar with, but maybe a definition of what additive manufacturing or 3D printing is would be helpful.
Yes, of course. So it's additive manufacturing or 3D printing, as you say, is quite the same technology. It's a new way to produce part using a layer by layer approach. we can divide the big two items between the materials, so polymers or metal. This is the big main differences. And we use metal 3D printing in-house to produce fluid power products. And also in the 3D printing, we have different technique. The first technique that we introduce is laser power bed fusion. So I can describe a little bit this technology.
Yeah, please.
Where the product grow layer by layer with a metallic powder. And the metallic powder is melted by a laser in accord to the design. In this way, we grow the product, again, layer by layer, but the mechanical properties that we have at the end are very high compared to other process like sintering, that it's a different approach. So what we have done a few years ago was to make some experimental and research on the technologies, additive manufacturing technologies, and we found that laser power bed fusion is the best one. At the time, it was the best one for our application. And then we decided to invest in the technology, creating our own department inside Hydro, exactly alongside the conventional manufacturing of hydraulics component.
That's fascinating.
And like I said,
and you were doing that as Hydro prior to the acquisition by Desktop Metal, correct?
Exactly. We started exactly 5 years ago with our internal department of additive manufacturing. And at the beginning, we decided to invest in this technology because we have seen the big advantage to create toolings and prototypes for our, conventional manufacturing of hydraulics. But more and more we understood the benefit of this technology. We really were amazed by the big potentiality. And that's why we started to create a new generation of hydraulics component made by additive manufacturing.
Sure. Yeah, my understanding of, in fact, if I go back in our archives, I know that we had an episode on 3D printing early in our history. I'm going to forget the gentleman's name who was on the show, but I think he was from one of the 3D printing manufacturer companies, the companies that make 3D printing machines. And at that time, we talked about applications for the fluid power industry really being focused on castings and prototyping and things like that, not on the actual production of real parts, if you will, real components, actual valves, actual manifolds. I get the sense that has changed a lot in the year and a half or so that previous episode was recording. You guys are actually making production level parts from a 3D printing process, correct?
Yes. We started, of course, with prototypes.
Yep.
But today we have already in our standard product range some NG6 C-top 3 NG6 valves, on-off and proportional, produced in additive manufacturing. The main body is not anymore in cast iron, but it is in stainless steel, 316L. And we share the internal components and we share the coils and the other components are not in additive manufacturing. So the combination of a traditional part with additive manufacturing give us the opportunity to create a standard valve in our catalog with very high performance and also where we don't need to have a specific stock because we print on demand the valve that we need. So this is the first step in a different way to produce valves. And with Desktop Metal now, we have the opportunity to push in this direction because with their technology, we are able to produce faster and cheaper.
Yeah.
And so we are not talking anymore about niche production or small batches, but the target in the next 2 or 3 years is to really use this technology for mass production. And that's the reason why at the end Desktop Metal decided to acquire Hydro because we have knowledge in hydraulics and also in additive manufacturing. So we are like a bridge between the two different worlds.
Yeah. Well, I want to make sure I heard you correctly there, Alberto. It sounded like you're 3D printing the valve body, but some of the internal components of the valve are still manufactured and assembled through a traditional means. Is that right?
Exactly. For example, the body is 3D printed, but the actuators, the solenoid, is traditional. And also the electric coils are traditional parts. So we implemented the additive manufacturing only in the critical part, which is the body. Mm-hmm. If you think to a stainless steel body, today you have only two options. One is to machine from a solid bar in stainless steel. It is expensive and you cannot replicate all the curved channel you normally have in the casting.
Right.
And if you want to cast stainless steel, it costs a lot and you have to invest a lot of money in the mold, and it makes no sense for small volume because, you know, in fluid power, stainless steel valves are not the big part of the market. So in this way, additive manufacturing is a perfect combination of maximum performances and also time to market very fast.
I was going to ask about that very piece of it because that's increasingly a concern in the marketplace, if you will. You know, and you just listed off a lot of advantages for this manufacturing technique, if you will. But do you have any sense of a comparison in terms of time of production from the more traditional way of making this valve to using additive manufacturing? How much more quickly can you make those parts as a result?
It's a good question because if we need to produce 5,000 valves, for example, I think today is faster and cheaper to produce these valves by casting. Mm. And probably not this year because you know that the supply chain is totally lost. But
right.
in general, it's possible to have this casted body in 8 to 10 weeks. The problem is when you need, for example, 100 pieces with a special material like stainless steel,
right.
or with a special design. With a normal supply chain, it's quite impossible to have this type of solution. And you have to adapt normally your application with the traditional valves that are present on the market. And in many cases, the technical choice is not the best one. And in this case, with additive manufacturing, it's possible to print and produce, or also to design and produce the valve in 3, 4, 5 weeks. I'm not able to print in 4 weeks 10,000 valves, but maybe right. 100 custom made for the application.
That's great. So there's clearly still a lot of advantages given the specific kind of product that needs to be produced. You can get it out much more quickly, it sounds.
Yeah. And another important approach is also for the time to market of new products. Yep. This is one of our typical way to work, because when customers are looking for new product, new solution to put on the market, if they have to wait 6 months to produce the mold and the first prototypes and then to go to the market, they waste a lot of time. And in some cases, the customer became cold and look around for other solutions. With additive manufacturing, you can pass through from the idea to the real part that can be tested on field in 1 month.
Mm-hmm. Well, great. I'm sorry that we've reached the point in our show where we need to take a short break so that we can bring our listeners up to date on a few other opportunities available to them in the fluid power industry. But we'll be right back to our conversation with Valeria and Alberto in just a few minutes. Okay, we're back from our break. I'm speaking with Valeria Tirelli and Alberto Tacconelli of Hydra, and we're talking about their 3D printing capabilities for fluid power valves. And I was just about to pivot and ask them more about the applications that these 3D printed valves go into and what kind of advantages they offer for either performance or other kinds of attributes on those machines. So we talked earlier about you guys are selling into both mobile and industrial markets. Are there any particular machines or end markets that these 3D printed valves are ideally suited for?
Yes, we have already done a very nice study with CNH Industrial. So for mobile application, in particular for the tractor. And in this case, we analyzed a manifold, an hydraulics manifold, and we decided to review the actual design using additive manufacturing. So the manifold collects the electro-hydraulics component as well as the mechanical component necessary to control an automatic gearbox. In this case, so in the conventional manufacturing, we have two separated manifolds, while with additive manufacturing, we were able to redesign these two components and create only one body. So from two components, we reduce it to only one part. So this is already one advantage because we avoid the assembling. That means time and also the potential leakage, oil leakage that normally we have between the connection of two manifolds. But that's not all. We also were able to reduce the weight using additive manufacturing, about 35% of weight reduction. And again, this is a very good advantage when we are speaking about a mobile application because less weight means less fuel consumption.
Right.
And of course, this is a benefit for the whole systems. But also in the case of the lead time, we achieved a very impressive lead time when we are speaking about the comparison between casting and 3D printing. Because from 12 weeks of the conventional, manifolds, we reduced the delivery time only to 4 weeks.
Wow.
So again, yes, a very big improvement in the lead time. And also we tested the manifold at 1 million cycles to prove that with additive manufacturing, we are able to reach high mechanical properties. So again, this is a very nice case study done with CNH Industrials.
Yeah.
And we hope that for the future, also big company for mobile application, they will think more to use additive manufacturing for, specific component, not for all the hydraulics systems. But we see that there are a lot of benefits.
Yeah. Well, that's a great, again, description of all the benefits. And the one that really zoomed out at me was anything smaller and lighter that does the same job on a piece of mobile equipment is going to be advantageous because of the fact that you're driving it around, right? So in an industrial application, it's less important for it to be small and light, but on a piece of mobile equipment, it's just essential for all kinds of reasons. So that sounds like
sure. And also, if we think that in the near future, all these mobile equipment will be electrified, and so lightweight means better autonomy and better distance that you can have with a single battery charge.
And I'm sorry if I missed it, Valeria, but what material was the manifold constructed of? What was that, stainless steel or?
Aluminum. No, it was in aluminum.
Aluminum. Okay. So there's the ability. I know metal printing is something that it continues to innovate, and as little as 4 years ago, there was no such thing as printing with metal. And now it seems like you can print in almost any metal. Is that the case, or what's your perception of that?
Yes, we are improving, the technology is improving a lot. And today it's quite easy to print aluminum, stainless steel, and we print also nickel alloy for special application. There is copper, really a lot of opportunities. We are talking also about, in some cases, hybrid solution with multiple material in the same job. My feeling is that we are in the same position that many years ago, where at home there were only a small printer to print a black or white piece of paper.
Right.
And today you can print whatever you want at home, also newspaper, very easily, and the technology is only 10 or 20 years old.
Yeah.
And we are making the same, but printing metals and not newspaper.
That's an interesting analogy. Yeah. It's, if anybody remembers the old dot matrix printers.
Exactly. Very noisy, very.
Yeah. And that's what we have today is completely different from that environment. So it sounds like some similar innovations are taking place here. So I was also curious to learn more about, Valeria, you said that the manifold had been tested and stood up well to the pressure and environmental demands of the real application. I think that's another area that people remain a little bit suspicious of. Will the 3D printed part hold up to the reality of a working fluid power system? You've shown that that's the case with this, correct?
Yes, but this also was, our history at the beginning, because before we decided to invest in additive manufacturing, we want to be sure that it's a good technology.
Right.
So we spent almost 1 year making, experiment, and we were supported also by the Italian university. Because as hydraulics manufacturer, we want to be sure that the technology can give us high mechanical properties, no failure, no cracks. So everything was working fine with a 3D printed valve or a manifold. And in this specific case of the CNH industrial manifold, we decided to perform a test at 1 million cycle in the CNH test bench. And the test took some months, I think at least 6 months. So it was really, well done test. Both impulse pressure cyclic endurance test, and at the end we have seen that the test was performed without failure of the component and no performance derate. So we can really say that it's a good technology. Of course, it depends on the design. It depends on the technique used for producing the 3D printed manifolds. But at the end, we can say that the CNH validated the 3D printed manifold for their application.
That's great. Yeah, another piece that really caught my ear was the way in which you can. I don't know. I'm not sure quite how to ask this question. So let me struggle through this. If I heard you right, the 3D printed manifold replaced 2 separate manifolds on the CNH vehicle. And one of the benefits of doing that, one of the reasons you could do that is because the design process for the manifold that's being 3D printed allows much more freedom and flexibility for the fluid channels, if I can call it that go through the manifold. And that allows you to do things in a 3D printed environment that you just plumb can't do when you traditionally drill holes in a manifold block. So maybe Alberto can speak a little bit more about that process and how does that work and what are some of the advantages there?
Yes, you are right, because with additive manufacturing, I can say that we normally design holes. We started to design holes and the connection between port A to port B. Mm-hmm. And after that, we have all the connection in place. We started to add material. And the material that we put around the hole is according to the pressure inside the hole. So it's a different way to design the parts, but doing this process, it's quite interesting to discover that normally in the traditional manufacturing, we have at least 60% of the material, which is totally useless for the application, right, from the fluid point of view. So we design the parts using the fluid point of view and not the raw material point of view, which is the traditional way to design a manifold or valves.
Yeah, that's an interesting perspective. That really you start with the fluid and where it needs to go, and you build the manifold around that. If I heard you exactly right? Yeah, so that's another area that I'm curious about. Hydro must have specific expertise in that area. That's not a skill that is taught very much, right? I mean, to what degree does this require a new engineering design approach compared to more traditional manufacturing? It must be very different.
Yes, and mainly I think it's a different mindset. In many cases, this was also our experience with our engineer. We used to design parts in the traditional way because it is the traditional way. We don't know exactly why we are designing in this way, but it's the history. When you are forced to design in additive manufacturing, all this history is gone, and in this case, you discover new solution, new opportunity to create also innovative parts and valves. In the traditional way, if you want to make a hole of 1 millimeter and 10-inch long, everyone say that you are crazy and bad technician.
Right.
But in additive manufacturing, is quite easy, and you can make this hole also with a strange path. And maybe you'll discover in this way a new function or a new optimization of your components. You are not a bad technician, you are like an artist.
Right. Yeah, that's a good way of describing it. Exactly. You have to approach the end goal in a completely new way. So that's exciting.
Yeah.
I wonder if either one of you has any sense of how prevalent additive manufacturing is in the fluid power component production these days. Do you guys have a lot of competitors? Are there a lot of other companies that are doing this?
Not so much. Not so much. Valeria?
Yes, no, exactly. We started, to exhibit for the first time 3D printed hydraulics component in the Hannover Messe, and it was 4 years ago.
Mm-hmm.
And at that time, we were, alone. And we really disrupted the fluid power hall.
Yeah.
But more and more, we see now that other fluid power companies start to investigate. At least investigate 3D printing. We were a kind of pioneer, so maybe we can say we tried to, inspire other big companies. Some of them already found a good application of 3D printing because from sand casting, for example, or prototyping. So there are many different applications, but hand application and functional parts, we see some fluid power products in a special sector, like in aerospace,
mm-hmm.
or, for example, in oil and gas industries. So in this application, we see more and more fluid power products. In the, industrial and mass production fluid power, I think it will take more time to see more 3D printed parts.
Yeah, there's.
Give us more time, and you will see.
I'll let you guys take over the market. Obviously you've got a nice head start. And as we said earlier, the Desktop Metal acquisition is going to be huge for your capabilities, I'm assuming.
Yes, exactly.
Yes.
Well, that's exciting. So as we come up on the end of our time together here, I wonder if you touched on that just a little bit, Valeria, but how do you see this growth happening in the industry over the next couple of years? Is this being driven by are the OEMs asking for this product, or is this innovation that has to be pushed out to the customer? What's your view on that?
I think the customer will be pushing the use and the adoption of 3D printing in the fluid power sector, because we see that more and more customers needs fast delivery time and also needs more sustainable product. And what we can say that in some cases, additive manufacturing can really help to reduce the CO2 emission. It means, for example, to use less material to produce the part, and then to have more efficiency in the hydraulic systems. For example, the case that I explained to you, the manifold that is 35 lightweight compared to the conventional manifold. it means less fuel consumption, so a better performance. And more the end customers need part with higher performance. So I think that the customer will drive also fluid power manufacturer to use 3D printing.
That's great. Well, it's something we'll certainly be keeping an eye on. And as I said, we've talked about additive on our show in the past. Something tells me we're going to talk about it again in the future as things continue to innovate and evolve in this space. So that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Valeria Tirelli and Alberto Tacconelli, who have been my guests on this episode. If you'd like to connect with them and learn even more about their products and their company, the best way to do that is via their email addresses, and we're going to put a link to those addresses in the show notes for this episode so you can connect with them. Remember, if you like our podcast, please follow us on Twitter. We're there at the NFPA, and keep sharing those innovative and interesting uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show is in March of 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are produced by Maddie Parise, NFPA's Communications Manager, and I'm your host, Eric Lanke, reminding you to join us next time in the forum.